A perfect number is a whole number that is equal to the sum of all its factors except itself. For example, 6 is a perfect number because its factors 1, 2 and 3 add to give 6. The next smallest is 28, the sum of 1 and 2 and 4 and 7 and 14. Throughout the ages, people have looked for some kind of mystical significance in perfect numbers. The ancient Christian scholar Augustine taught that God could have created the world in an instant, but chose to do it in a perfect number of days, 6. Early Jewish commentators felt that the perfection of the universe was shown by the moon's period of 28 days. The next perfect numbers after 6 and 28 are 496, 8,128, and then a big jump to 33,550,336. As René Descartes pointed out, perfect numbers, like perfect men, are very rare. All of them end in 6 or 8, though what seems to be a regular alternating pattern of 6s and 8s for the first few perfect numbers doesn't continue. All of the form 2 to the n minus 1 times 2 to the n minus 1, where 2 to the n minus 1 is a Mersenne prime. So the search for perfect numbers is the same as the search for Mersenne primes. The largest one known is 2 to the 82,589,932 times 2 to the 82,589,933 minus 1. Written out in full, it involves just under 50 million digits and starts and finishes as shown here. Two important questions about perfect numbers still haven't been answered by mathematicians. Are there infinitely many perfect numbers? And are there any odd perfect numbers? A pseudo-perfect number or semi-perfect number is a number equal to the sum of some of its divisors, for example 12, which equals 2 plus 4 plus 6, and 20, which equals 1 plus 4 plus 5 plus 10. An irreducible semi-perfect number is a semi-perfect number, none of whose factors is semi-perfect, for example 104. A quasi-perfect number would be a number n whose divisors, excluding itself, add up to n plus 1, but it isn't known if such a number exists. A multiply perfect number is a number n whose divisors add up to a multiple of n. An example is 120, whose divisors, including itself, add up to 360, which is 3 times 120. If the divisors add up to 3n, n is said to be multiply perfect of order 3 or triperfect. Ordinary perfect numbers are multiply perfect of order 2. Multiply perfect numbers are known of order up to 8. And that brings this video to a perfect end.